DHCP. Let us explore the core management concepts of the Dynamic Host Configuration Protocol, or DHCP, as we have discussed previously. DHCP is the automated system that assigns IP addresses to devices the moment they connect to a network. However, simply letting a server shout out addresses at random is not enough for a professional enterprise environment. To maintain order, security, and reliability, a network administrator must master the 4 pillars of DHCP management: the scope, exclusions, leases, and reservations. Understanding these concepts is vital because they represent the difference between a home-style network that works by accident and an enterprise-grade network that is designed for maximum uptime. Whether you are managing the handheld scanners at a postal distribution center or setting up a secure server room, these are the levers you will pull to control your network traffic. The foundation, the DHCP scope. The very first thing an administrator does when setting up a DHCP server is define the scope. A scope is an administrative grouping of IP addresses for computers on a single subnet. Think of it as a pool or a bucket of available identities. When you create a scope, you are telling the server, you are responsible for this specific territory. You define the starting IP address, the ending IP address, and the subnet mask. For example, a common scope might range from 192.168.1.10 all the way to 192.168.1.200. But a scope is more than just a range of numbers. It also contains the standard options that every device needs to actually use the internet. When a computer receives an IP address from a scope, it also receives the address of the default gateway, which is the router that leads out of the network, and the addresses of the DNS servers. Without these options, a device would have an IP address but would be completely unable to load a website or find a printer. Guarding the territory, exclusions. Once you have defined your broad scope, you must immediately deal with a major technical problem: IP address conflicts. In any professional network, some devices must have a permanent, manually typed identity. These are called static IP addresses. Your core routers, your physical servers, and your high-volume network printers should never change their addresses. If a server's address changed every week, no one in the company would be able to find their shared files. This creates a danger. If you have a server manually set to .50 and your DHCP scope includes that same number, eventually the DHCP server will try to give that address to a random laptop. When 2 devices try to use the exact same IP address at the same time, they both lose connectivity. This is a collision, and it can crash critical services. To prevent this, we use exclusions. An exclusion is a specific address, or a mini-range of addresses, within your scope that the DHCP server is strictly forbidden from giving away. By carving out these exclusions, you create a safe zone for your static hardware. For example, you might have a scope from .1 to .254, but you exclude .1 through .20 for your routers and servers. The DHCP server will see those numbers in its list, but it will jump over them and start handing out addresses at .21. The rental agreement, DHCP leases. It is a common mistake to think that once a computer gets an IP address from a DHCP server, it owns that address forever. That is not how the protocol works. In reality, the computer is only renting the address. This is known as a lease. The lease time is a setting in the DHCP server that determines exactly how long a client can keep an IP address before it must ask for permission to continue using it. In a standard office environment, a common lease time is 8 days. The lease process follows a very specific mathematical timeline to ensure the network never runs out of addresses. When exactly 50% of the lease time has passed, which would be 4 days in our example, the client enters the renewal state. It sends a quiet, direct message to the DHCP server asking to extend the lease. This is called the T1 timer. If the server is online, it says yes, and the clock resets back to 8 days. If the server is offline or the message is lost, the client keeps its address and waits. When 87.5% of the lease has passed, about 7 days into the process, the client enters the rebinding state. This is the T2 timer. Now the client gets desperate. It broadcasts a message to any DHCP server on the network, yelling, "My lease is about to expire. Can anyone help me?" If the lease expires completely DNO server has responded. The client must instantly stop using that IP address. It will likely drop its connection and assign itself an APIPA address starting with 169.254, effectively cutting it off from the rest of the network until a server comes back online. Why do we use leases instead of giving addresses forever? It is about address conservation. Imagine a coffee shop with a small network. If every customer who walked in and used the Wi-Fi kept their IP address forever, the shop would run out of addresses in a single afternoon. By using short leases, perhaps only 1 hour, the DHCP server can reclaim addresses from people who have left, making them available for the next customer. The VIP treatment, reservations. Finally, we have the reservation. This is a hybrid approach that gives you the best of both worlds. A reservation is a way to ensure that a specific device always receives the exact same IP address from the DHCP server every single time it connects, unlike a static IP where you have to manually type the address into the device's settings. A reservation is managed entirely on the server. To create a reservation, the administrator must know the device's MAC address, or Media Access Control address. This is a unique 12-character hexadecimal code that is physically burned into the device's network card at the factory. No two devices in the world have the same MAC address. You tell the DHCP server, whenever you see a device with this specific MAC address, always give it this specific IP address. Reservations are incredibly useful for devices that need a consistent identity but are difficult to configure manually. For example, if you have 50 network printers, it is much easier to manage their addresses from one central DHCP server using reservations than it is to walk to every single printer and type in settings on a tiny, frustrating screen. Additionally, if you ever need to change your DNS server addresses, you just update it once on the DHCP server, and the next time the printers renew their reserved lease, they will automatically receive the new settings. Summary of the 4 pillars. To keep your network running smoothly, you must remember how these 4 concepts interact. You start with a scope to define your overall pool of addresses. You apply exclusions to protect your manually configured, static, servers and routers. You manage your leases to ensure that temporary devices don't hog addresses after they leave the building. And you use reservations to provide a permanent, reliable identity to important devices while still keeping all your management in one central location. By mastering these 4 pillars, you will be able to design networks that are organized, efficient, and easy to troubleshoot when things go wrong.